The Biodesign Institute represents Arizona's single largest research infrastructure investment in the biosciences. Its talented researchers are pioneers of a dynamic new academic research model and hub of 21st century innovation, with the Biodesign Institute's convergent technologies and fields of research focusing on biomedicine and health outcomes, sustainability, and security. Created on the premise that scientists can overcome complex societal issues by reimagining the design rules found in nature, the Institute's researchers are addressing an expansive array of global challenges by creating bio-inspired solutions, including new vaccine discovery and delivery, early detection and treatment of cancer and infectious diseases, techniques for detecting and removing contaminants from air and water, and the application of nanotechnology for biomedicine and electronics. To advance its bio-inspired research mission, the Biodesign Institute has established 11 different research centers and has more than 200 active research projects ongoing. Its 65 tenured research faculty, who include 1 Nobel laureate and 4 National Academy members, publish in top-tier, high-impact scientific journals and collaborate with research and commercial enterprises around the world. One specific project being researched is the detecting and removing of contaminants from water via DNA protein fusions from the enzyme topoisomerase, which regulates the winding and unwinding of DNA. Whenever there is a pathogen present, the two halves of the enzyme fuse, and this creates and releases a black color into the water, similar to that of ink being released, indicating that there are indeed toxicities present. The founder of the project, Ryan Moeller, will elaborate more on the subject.
Hello, my name is Ryan Moeller. I'm a molecular biology and biochemistry major, and today I'll be talking a little bit about my research. I'm working on a molecular biosensor that will detect pathogenic species in a water supply. So my research started out with iGEM competition. iGEM stands for International Genetically Engineered Machine Competition. It's a synthetic biology competition consisting of undergraduates, and actually, despite having like a shoestring budget and despite only being like undergrads, they actually put out some really fantastic research. And in fact, one bit of research that really stuck with me during my sophomore year was they engineered bacteria to solve Sudoku puzzles, and I remember that specific research got me really interested in iGEM and synthetic biology, and so I joined ASU's 2012 synthetic biology iGEM team, and our project was to create a biosensor that would detect pathogens in water. And so this actually started off more of like a global challenge. Diarrhea is a large problem in developing nations, and it accounts for billions of deaths and is the leading cause of infant death in developing nations. And so we wanted to do something about this. And so the largest pathogens that are causing this are, for example, like pathogenic E. coli, dysentery, different bacterial contamination that's found in water supplies. So we wanted to see if we could use synthetic biology to find a way to determine what samples or what water sources were clean and safe to drink and which ones weren't.
So I'm a scientist. I like visual demonstrations, so I put together a demonstration for you guys. So the molecular probes are kind of like these two apple halves. It's a split enzyme that apart it doesn't work as an enzyme unit, but say for example you have your two enzyme halves and you have a pathogen which represented here as the peanut butter, so that it causes the two halves of the enzymes to stick together into a functional enzyme unit, and this functional enzyme unit is then able to cause a color change from clear to black in the solution of water that you have.
The Biodesign Institute works as a hub not only for top-tier researchers, but as a training ground and collaborative area for graduate and undergraduate students as well, and provides opportunities unlike any other for both the novice and the expert. Truly, with the Biodesign Institute, the future possibilities for research and solutions are infinite.